Now we will see another component, important component is static bypass switch. SCRs, silicon controlled rectifier also it is called. Logic, solid state switch using back to back SCRs transfers load from inverter to bypass in less than 4 milliseconds. Okay, during inverter failure or overload. If it is not being catered through inverter, then it will switch to bypass. No moving parts is equal to high reliability, monitors inverter output and bypass inputs continuously for safe transfer. What it is monitoring? When to switch the output, inverter output. There the monitor is there, and on that it will take the decision whether to put it on bypass or even bypass output. It is monitoring at both the levels so that it can take precise decision for the safe transfer whether on the bypass or on inverter. Now automatic transfer triggers inverter overload is less than 110 to 125%. Inverter overload should be less than 110 or 125%. Okay, overload should not happen. Inverter fault or output voltage out of tolerance, DC link voltage collapse, temperature shutdown. In this case, how many cases? Overload 110 or 125%, inverter fault, then output voltage or out of tolerance, it is out of tolerance, and DC link voltage collapse and temperature shutdown. In this case, this will trigger and it will put the load on bypass. Now transfer requirements. What are the requirements whether to transfer it to the bypass or back to inverter? Bypass and inverter must be in phase. In phase we have seen, if it is at 0, both should be at 0. If it is at 90, both should be at 90. There should not be any gap. It should not start at 0 and it is at 15. No. The tolerance is 10 degrees. Plus or minus 10 degrees is okay. It should be less than that. Then voltage difference is less than 10%. Okay, 230 volt, 10% is 23. It should be less than. Then frequency should be synchronized. 0.1, we know that. That is the tolerance. If not met, transfer blocks. These all things are done by your software or firmware. Everything is there in the switch. Now transfer logic. Okay, transfer logic after fault clears. Now how the bypass will be back transferred to inverter, that is we are saying. If fault is clear, automatic transfer to inverter, delay 10 to 30 seconds to stabilize. Now fault is clear, 10 to 30 seconds we will wait. If anything happens, it will happen within this window. Okay. If it doesn't, then within 10 to 30 seconds it will switch the load to inverter again. Okay. Now if it doesn't happen, then maybe static switch has gone faulty. Then manual intervention possible if needed. If needed. See, 99.99% of the time this doesn't happen. Okay, manual intervention is not required. But if in case, then you need to do that. Logic if doesn't work, then manual intervention is required. Bypass source quality. See, bypass inherits raw mains quality. Raw mains quality will be there within bypass. It is not like created proper sine wave. It is as per the raw. Okay. No filtering is there. Load sees voltage sags, transients during bypass operation. These things, quality issues will be there if load is on bypass. So as soon as possible, we need to bring back it to the main source. That is why another n plus n redundancy is required. N plus 1 or n plus 2 redundancy is required in case of critical load, so that all the time load will be catered through UPS only, not through raw. Okay. See, many cases I have seen the critical UPSs, bypass is connected to our lighting UPS. Okay. So that if any case, the design is done like that, so that even lighting UPS or another UPS, standby UPS should take the load. Okay, so you can take the decision in consent with the UPS vendor. Don't bypass them. Don't try to use your own head. Now you know that. Just because you know that, you should not try it directly. UPS vendor should advise that, and then you can connect that bypass to another UPS. Okay, that is the safest way. They will advise you properly. Now, critical failure scenarios, when it fails. SCR failure in short circuit. SCR can fail in case of short circuit. Both inverters and bypass feed load simultaneously is equal to catastrophic damage. Both loads, if it is fed, because SCRs are not working, it is failed, then it is catastrophic damage. You will see fire inside the static switch. So SCR failure in open circuit. No bypass protection during inverter fault. Bypass protection is equal to total blackout. Okay, when SCR failure in open circuit. So what will happen? No bypass protection. Bypass will not be protected, and during inverter fault is equal to total blackout. If inverter fails, bypass will not be there to support. Okay, then control failure, unwanted transfers causes load disruption, and then FMs must test bypass monthly. Waiting for emergency to disaster failure is too late. So this thing, when it is done, when you are doing online maintenance, just look at your schedule, UPS vendors maintenance schedule. During online maintenance schedule, you should check all the static switches if health is correct. Now very sophisticated softwares are there. They will directly tell you whether your static switch is healthy or not, or if there is any problem. Then DC bus temperature also is another indicator for UPS, and here you should do it monthly. Okay, monthly it is advised, but just check with your UPS vendor whenever he is doing online maintenance, whether it's quarterly, bi-monthly, if he is checking the health of your STS, static transfer switches. Okay, now we will see the construction. Okay, block diagram and construction, and how exactly the STS works.